Hi guys, it's design time again. Yeah, it's quite a while that we made a design, so let's do it again. And this time it will be a quite extensive one. So why do I show you this beautiful, beautiful tubes, vintage tubes? You think I will do something with that, transmitter or something? Well, not exactly, not really. This video is the first of a series that will be about building a high voltage tube power supply. Not made with tubes, but made for tube projects. With anode voltage, screen voltage, grid voltage, heating voltage, everything. But in a modern way, all of them with switch mode technology, switch mode power supplies. This is something I wanted to do for quite a while now. I started pieces of it, I left it, do other things. Yeah, I change my mind all the time. Yeah, when I see something new, it's interesting, I leave the old one. But this time, you remember this thing, what I showed you? It's a design a couple of videos ago. It is a controller board with a TL494 or newer ones, and with a dual gate driver on board. And this one will be the base or a part of the power supply that I'm going to design. So, and we come now for the reason why we have this blue box behind us. The PCBs that I showed you, this one, of course, is from JLCPCB. I use them all the time for years now. So I think since they exist or since they have the service for individuals too. And this time, I did not only made PCBs there at GLC, but I tried for the first time their PCB assembly service. And what did I do? Yeah, my boards here that you see, of course I could do them by hand. 5 boards are nothing. They are made so fast. But I wanted to try their service. Here I want to thank JLCPCB for sponsoring these beautiful boards. When I just had a look on their website, I found just a few new interesting features that they offer. One of them is called Via in Pad. That's very interesting. Perhaps not for everybody, but if you are dealing with PGAs or FPGAs, it is a really helpful feature. That means you can have a via in a pad. You had that before, but it costed, and manufacturers don't like that, because it's a pain when you have to solder something that has a hole in the pad. The problem is that mostly the solder will be sucked at the bottom of the pad, and you can have problems with the connectivity. So for now, JLCPCB is offering via in a pad for all the PCBs for free, from 6 layer up to 20 layer. Only up from 6 layer. 1 or 2 layers and 4 layers are not included, but up 6 layers and upwards, this feature is free. And it is very interesting because if you have to do with FPGAs, but you will say, okay, and who is making six layer PCBs? Well, I did a few times, and it was quite a pain when you have FPGAs or PGAs with 1 million pins to break out. So this feature is very interesting. If you want to know more about it, I will put a link in the description of this video, where you can see more information and a video on what exactly is meant. But for now, let's have a look what is the main purpose of this video. The main purpose of this video is, let's put this away, of course, is to use this as a small part of the whole. And the idea is to design this, a high voltage DC-DC tube power supply that will be powered from a Server PSU that are really, really cheap, that can deliver 12 volts and at least 83 amps to 100 amps. So what exactly do I plan to do? Let's go. I made a diagram here with a concept, what I want to do. So first of all, we need an anode power supply for the B+, that of course switch mode and fully isolated. It will be quite flexible. Flexible, I mean that depending on the transformer and on the topology, on the output topology, you can have either a 400 volts, 500 watts raw, and raw I mean without a doubler, or you use a doubler behind that and you will get 800 volts, 500 watts again, or with a different transformer that I will show you in a jiffy, you can have 500 volts and between 700 and 800 watts. Of course, it will be completely current and voltage regulated and adjustable. And of course, I will use only high side current sensing. Topology will be push-pull. Another criteria for the design is to use off-the-shelf parts. I'm not going to wind any transformers or any other inductors. Perhaps the one of the, if I want an inductor, it is maximum a toroidal with a few turns, that's it. But really high voltage transformers, no. For what? You can get them. And look what I mean. Here you have just a few transformers that I plan to use. 500 volt, 700 to 800 watts. These are 400 volts for 500 watts. And they are quite beefy. Yeah, look. Nice and heavy. All for push-pull, 12 volts. And here we have one for 150 watts, again 400 volts. And the big Bertha, this one, is a EC49 core. This will work up to 40 kilohertz, can deliver up to 800 watts. This is, I always design to make things, when I do it for myself or for others, repeatable. Of course, if it is a professional design, a paid professional design, this is, I'm not even discussing it, to do something, not even for a prototyping phase. Yeah, these things will be done either in China or in another manufacturer here in Europe, or when I do projects like that, like this power supply that I plan, I take what I can get and I build the electronics around it, not the opposite. Because this is the cheapest way and the easiest way to deal with the magnetics. Again, if it is a professional design, the magnetics will be custom designed. But this is not a professional, or this is not planned to be a professional design. So I'm getting what I get. I'm taking what I get, sorry. And I do the electronics. So let's go back. Oops, that's too much bad. This was the high voltage power supply. So you can see this thing is not something to play with. This is something that will not only hurt you, will send you to see your maker if you're not careful. So I'm just saying it from the beginning. If anybody will follow what I'm doing in the next videos, you follow from your own. You know what you're doing, and you're doing it from your own will. Yeah. Just be careful with these things. So this is one of the primary parts. As the second part, or one additional DC-DC converter, because all of these are DC-DC converters, will be for the screen or an auxiliary voltage, and the the grid bias voltages. Again, isolated from the bus, from the 12 volt bus. And this one will be a smaller one. You will have raw up to 400 volts, and this time only 150 watts with this. Fully isolated, again. It will be adjustable, will be only the voltage from, I don't know if I'll make it 0. Zero makes no sense for tubes, yeah. Perhaps from 50 volts or something up to 400. And for the bias, you will have two outputs, as you can see here, grid range 1 and grid range 2. It will be from minus 25 to 0 with 5 milliamps, and minus 250 to 0, 5 milliamps again. I don't know, perhaps I will take something in between two, from 0 to 100, 5 milliamps. We will see as we progress with this design. We will see. Of course, all outputs of all of these modules will be short-proof, and this time this one will be a push-pull again in combination with a linear for the negative power supply. Now we came to the heaters. Let's start from here. We will have a heater voltage available, 5 volt up to 10 amps. But even it is only 10 amps, it will be a 250 volt power supply. That's only internally adjustable, not from outside. This will be a fixed 5 volt power supply. It will have a remote sense option, because if you have not all too thick wires, or you go, I don't know, 30-40 centimeters, and you need 5 or 10 amps for 5 volts, you will have a voltage drop, significant, and this is not good for the heaters of tubes. This will be, lower, of course, the output power. Anyway, an remote sense option will be available. We will see how we'll do it. Internally, it will be fully current and voltage regulated, adjusted. Again, high side current sensing, always. And I will show you why. And this will be a synchronous buck with probably 150 kilohertz. Then we have a second module that will give you 6.3 at 10 amps. Again, the same specs as the 5 volt module, 250 watts again. Of course, it will be able to deliver more than 10 amps, but I will limit it to 10 amps because it's not necessary for this power supply. Again, synchronous buck, 150 kilohertz, high side current sensing and remote, high side current sensing and remote voltage sensing option. And the last module will be again for heating for all the voltages that are above 6.3 volts. I'm not really sure how I will make it. Will I do it as an isolated one, like for example a half bridge or a forward? I don't know. Or I will make a buck boost or only a boost. Everything is open. Again, 250 watts. I will limit it for 21 voltage, adjustable from outside. It will have, of course, current and voltage externally adjustable, remote sense option, and high side current sensing again. And why I'm saying it all the time, you will see what I mean. Yeah, the topology to be discussed. I don't know. We will see. So as you can see, this is quite an extensive project, what I'm planning here. And all of it, of course, this is only just a block diagram, nothing else. There is a lot of electronics around that are necessary. But you will say, why not use one of these things for, you see it? Yeah. For, at least for the heater power supplies that are non-isolated. Honestly, this thing works perfect. I loaded it to the full that this thing should be, almost 400 watts, and it works, and it doesn't even scream or get too hot or something. Yeah, it's a nice design. It uses a synchronous buck converter, buck chip. Ah, come on, it's wobbling. And it's an LM25116. It's a very nice chip for what it is meant to be. Here you see the sensing, and of course this is a low side sensing. They put the sense resistor in the ground line between input and output. And here we start to have the problems. Look what I mean. Let's go way back again. Get it to completely, yeah. For example, here you have two of these modules, yeah? On the left side, you have the input, on the right side, you have the output, you have your load. One moment. Let's take this thing so you don't have to see all the time on my fingers. So, the ground, as you see, is opened, and in between there is a sense, the current sense resistor. This is the cheapest and easiest way to make a current sense, low side current sensing. And you have here the output through the load, and the sensing is made here. Perfect, no problem at all. Only if you use this thing standalone. If you take a second one for the second heater, voltage, for example, you have the same topology two times. And again, you have the second sense resistor, but at the appliance, at the end, you have a common ground. So these things are connected. So what we see here, that this resistor, sense resistor, and this one, through this connection and this connection, are put in parallel. This will not work. You will get a lot of problems, and this is the smaller of all problems, because perhaps there is a necessity to have the input ground connected to the chassis ground of the appliance. Then it is much worse, because you are shorting out the complete sensing circuit here. So that is why, for my design, it's a no-go. If it is standalone, if you use only one of those, it's perfect. Use it. Why not? It is. Honestly, I would use it too, but I need more than one synchronous buck adapter that are not converters that are not isolated. This is why it is not for me an option. option would be if the sensing would be on the high side, here and here, like that. Here we have, for example, a high side sensing. You can use, of course, one with a low side sensing, and again, you don't have any problems because here, this will go like that. The same thing is if you have low side sensing, but the whole thing is isolated. Then again, there is no problem at all. Yeah. It goes like that. And even if it is connected on the common ground, you have no reference to anything else but to this side. So that means that for me there is only two options, either high side sensing, all of them that I will do for all the bugs, or isolated that I will do for all the high voltage parts. This is how it looks. And this is why you should be careful when you use more of one of these, for example, these ones that have low side sensing, and put them even with the worst case that you can do is to put a common ground here. If you do that, it's gone. This functionality is completely gone. Even if you do it like that, you will have problems because you put these two in parallel. So this is what I mean. So this is why all of this stuff will be completely designed new. For these two things, the design is almost ready to go to make the layout. Again, I will try to use as much as less special parts. That means this will be probably TL494. And this is why I showed you this thing. Yeah? Why? It does what it should, it is cheap, and it is readily available all over the world. Everything else is much more difficult to use. If I would like to use that, yeah, the LM, but it's not that easy to design. Yeah, it is not built to be completely adjustable with current and voltage. The ones that I will do are, of course, adjustable completely. So this is why. Of course, the high voltage power supplies, these two are, yeah, have to be completely made from scratch. And this one, the high power one, is in the making. So this will be the project that I plan for the high voltage power supply that is 12 volt low voltage powered. When everything is finished that you see here, we will have a next phase, and this thing will be main powered. So everything will be here. So all of these problems that you have with the low side current sensing are gone, because all of them will be isolated. Yep, this is for today. I hope you like the video. Thank you again, JLCPCB, for sponsoring this PCB assembly and PCBs. The first part of the next video will be one of the heaters, because this one is almost ready. And yeah, of course I will make the first layout and check it. Probably will be a second layout will be necessary, but anyway, we'll see how it goes, and then we can play with those. So guys, thank you for watching. be careful when connecting these things, not even in parallel, but the grounds together, the outputs together. You will see what happens. Yeah, because on the left side, or if you have two different power supplies and you use them for the inputs and only the outputs are connected, the grounds are connected together, this should work too. But who has that? Yeah. If you have that, yeah, this will work. But here the design is to have a bus, a 12 volt high power, high current bus, and you have all the modules connected on that. Yeah. This is why we cannot use low side sensing. Okay, don't make it too long. Thank you very much for watching. Guys, if you like what you see, if you like my videos, if you like my designs, well, not this one, but this is what will happen now. Please press the like button, subscribe to my channel, and if you want, press the notification so you can get informed when I have new videos. Thanks for watching. See you. Cheers.